Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 241. Number of ways to rearrange sticks with K sticks visible. So actually I solved this with dynamic programming, and I actually did it. If you watch me solve it live, I'm gonna actually go through how can I quit on this? Oops, I did. If you watch me solve it live, you could actually see the progression of the full dynamic programming of top down, then to bottoms up, and then I even optimized to the whatchamacallit, to the space optimization trick. I'll go over it here as well, but you can kind of see me do it live, so that is an example. But yeah. So for this problem, let's read the problem first. So this is the number of ways to rearrange the sticks with K sticks visible. So join me on Discord, hit the like button and that. I always do a modular dance now, by the way. But for this one, I'm not gonna lie. I've seen this problem before. It was on binarysearch.com. I still got a wrong answer because of memory limited exceeded, which is something that I'm really annoyed about. And you'll see why in a second. And this is this is dynamic programming, so I'm going to go over with the code, but the idea is, and I'm going to actually, let me do a little bit better and bring up my trusty paintbrush. But yeah, but the idea here is that, where's my trusty paintbrush? Okay, so now you have, all these blocks, you have a ground, and now you're trying to put a block, right? For first block, you could put it anywhere. So let's actually, do the blocks from the biggest block to the smallest blocks. Okay, so now this is the biggest block. So the first block, it can go anywhere, so, just it is what it is. And then the second biggest block, there are two ways to do it, right? I mean, you could kind of see the two ways. One is if it's in the front or in the back, right? Makes sense. If this is in the front, then you see two blocks. Oops, that's terrible handwriting. And if it's in the back, then it's still one block, right? So that's basically the idea for now. And then now just kind of reducing this. I spent so much time to write this. But you think about these as, whoa, how did that color change? Technology is hard. Mistakes were made. But yeah. But now instead of saying, two blocks or whatever, you could say this is, in the beginning, you want to see K blocks, and here if you put a block in the front, then you only need to see K minus one block, right? And here if you put in the back, there's still only K left because this is hidden. And then now you have to, now you do it recursively, but let's only look at this side, because if the block is hidden, then you have the same state as before, which is, except for you have one fewer blocks to use, but it's still the same, and that is the same K, right? So let's actually look at this case for now, and yeah, and let's say now you're trying to figure out dirt block, and there are now three possibilities, right? As you can kind of see, again, you could see the one on the back really quickly. That's also going to be K minus one, and also here. It's all going to be K minus one because you don't change anything, right? Because it is, like it's getting blocked by the earlier blocks, so you don't really see anything. The only time you see anything is if this is all the way in the front, so then this makes it K minus two. So yeah, so then now look at that. That you can kind of see that there given n blocks, there are n minus way of getting blocked, and then one way of putting it in the front and getting seen. And of course, just to be, that's basically the idea here. And just kind of go back a little bit on the colors. That's basically the idea, though. And that is the recursive function, just in the interest of kind of being exhaustive a little bit. And this is a little bit yucky, excuse me. Yeah. You know, let's say we had that case earlier that was this, and now you're trying to add the orange, the thingy, and oh, this should be shorter, right? Note that in this case, still, they're n-1, and there's only one case where, you know, this shines in the front, right? And of course, this is going to be in this. Oops. This is going to be k-1. Where this is k from the top. So that's basically the idea behind this problem. This offset. I just noticed that the offset's a little bit awkward. Hopefully that was good enough. Well, that's a little bit awkward on the stream, but anyway, you get the idea. Hopefully, at least from this. I don't know how it recorded out. That's my bad. But yeah. So now we can look at the code, and that's basically what I do, right? If there are no blocks left, if k is equal to 0, we return 1, because that means that we all the k sticks are visible. Otherwise, I say blocks because maybe guess why. But yeah, and if k is not 0, that means that we still have blocks that we have to see, but we didn't get to see because, well, it is what it is, right? Because yeah, this combination just didn't lead itself to it. And then that's pretty much the idea here. Total this block is, so this is the count that goes in the okay, if I put this current block in the front, this is the number of count here, and then this is the number of count of if I put this block in a place that's not visible, right? And then you still have k that, you know, obligations that you have to do. This is if you already satisfied one less k. And that's pretty much it. Unfortunately, so I did this in about 3-4 minutes during the contest. Unfortunately, this gives me, where's my window? Unfortunately, this gives me, during the contest, a memory limit exceeded for some reason, even though, you know, you look at the constraints, and it's going to be, look at the constraints, and it's going to be n times k, for reasons that we'll go over in a second. And n times k is less than 1,000. So, I don't know. So this made me really sad, because 1,000, this should be pretty good, but still, sometimes Leetcode has its ways of disappointing you, I guess. But yeah, so my second thing that I needed to do was converting this to top down. I did actually create an n by k array, and I set this to yeah. And this is, you know, if you look at this matched the base case, because if n and k is equal to 0, then this is equal to 1, because that's how we throw this array, which, you know, yeah. And we're doing it in a different order. If x is 0, then every y is equal to 0. And this is, of course, this base case here. And then now we just have to transcribe the solution. I probably could have transcribed the solutions quicker, but I was just too busy being annoyed, to be honest. If you watch the video, you'll see me going, and I grunt a lot and grumble a lot. But yeah, but that's basically this formula here. And at the end, of course, we have to remember to mod. And that's basically the idea. And to be honest, when I was doing the contest, I was a little bit tilted, meaning that I was a little bit more annoyed, because I know that this has the same space complexity. This is still going to be n times k, but it's a more efficient n times k instead of putting it in the map. So I was like, eh. And I think if I was smart about it, I would actually spend the extra minute to reduce the space. But I think I was just too annoyed about it. So I was like YOLO, and you know, if I get another 5-minute penalty, I hate you already. Anyway, Leetcode. So I don't know. So that one, even though this got accepted, maybe tactically is a little bit off. And then yeah, looking at this, I actually transcribe it to the current solution. You could watch me do it during the contest. Or like I actually solved this after the contest, if you keep watching the video, where I basically changed this to this, and it's pretty straightforward, to be honest, because I also have a video that talks about how to do this optimization. I'll have a link below, or ask me in Discord if you need. But the idea is that we just replace we replace every instance of dp x minus 1 with pdp, which I say stands for previous dynamic programming. Naming is a little bit yuck. But yeah, but you look at that and look at this, then it's going to be, yeah, you're going to see that it is pretty much one-to-one. So yeah, I'm going to leave them both up. So here is the space optimization one. And in this case, I'm just going to go over, yeah, I'm going to go over the complexity real quick. But yeah, but this is, you know, for each, there are only n times k number of inputs. So this is going to be n times k time, which is n squared time in the worst case. Each one of these is all of one operation. So it's going to be all of n times k space and all of n times k time. And in this case as well, because we just transfer it to bottoms up, but you can see the space part way easier because now we have an arrays or two-dimensional matrix, and the time is also just 2 for loop, so you can kind of see everything clearly. Here we actually reduce the space to O of k. Yeah. Yeah, we reduce this space to O of k, and the running time though is still the same. It's going to be n times k. That's all I have with this problem. Like I said, I'm okay with this problem. Well, I have seen it before, but the memory limit exceeded kind of annoyed me. Not only because I got a wrong answer, because I think, you know, you look at the, I don't have to, but if you look at the timings, I saved at least 5 minutes plus another 5-minute penalty. So on this problem, I would have maybe gotten top 10, maybe top 12, something like that, top 15-ish at least, at worst. Like if you take 10 minutes off the, like I would have been, you know, so, or at least top 25, say. It's always good to be on the first page, but it is what it is. Sometimes Python gives you amazing times, and sometimes Leetcode is not sensitive to Python, and this happens. Let me know what you think, and you could watch me solve it live during the contest next. Well, people have finished with the contest already, so I'm a little bit behind. Mod. My computer is lagging. Not great. If I have to do this bottoms up, I'm gonna be sad. I mean, it's 1,000. Okay, fine. That's, come on, friends. Okay, that's. Did I do anything silly? No, this should be right. Okay. I don't know. I don't know why that's. That's just sad, I think. For me. I need to practice this more, to be honest. Let's see if this would work. Wait, I don't know why this is so silly. I mean, this, well, okay, that's a different case, but I don't know why this, like, why doesn't that work? That's not right. Did I miss something? Okay. Much slightly faster, but I don't even know if it just gives me a limit again. I'm gonna be sad. I mean, at this point, I consider it a moral victory, and we'll see. That's silly, though. Silly. I actually was worried a little bit about this because I should have done the pre-optimization one as well, the space optimization after getting memory limited, but I was just so doubtful about it that, you know, and I just really wanted to make sure I get it right first. I probably could have spent more time on it, but I was just like a little bit frustrated, maybe on tilt, to be honest, where and I mean until in that I was okay with getting a wrong answer if I had to make this optimization earlier, and then I would just do something like this, and then now I would start at 1. Something like that. This is roughly right. I mean, you could be a little bit better about the space efficiencies, but okay, maybe I have a typo somewhere. Oh, right. So I probably could have just spent an extra minute on that, but I was just so annoyed at this, to be honest, that top down doesn't work. Yeah, see, that looks good. So yeah, let me know what you think about today's contest, today's problem. Did you have the same annoyingness that I had on stuff? Yeah, hit the like button, hit the subscribe button, join me on Discord, talk about these things. I try to do most of these. So yeah, stay good, stay healthy. I'll see you next problem, and you know, to good mental health. Bye bye. Had to press the stop button.